Well, my name's Tim Kowalski. I'm the Application Support Manager for Wirtgen America and the HOM Rollers. I'm not a salesman, but I work with our district sales managers and I work with our dealers, with our customers, to make sure they know how to operate our equipment properly. My territory is US and Canada, so I get around to see a lot of different things. It's amazing how many places I go that nobody does anything the same, yet the principles of what we're trying to show you here are the same. We talk about best practices. I don't like to call them best practices because what's a best practice here might not be a best practice somewhere else. I call them suggested procedures, and then you guys can develop them into your own best practices. Some of the other things from the other presenters, and I want to acknowledge them and their expertise, but we all have a passion for what we do. And we want to express that to everyone else. We want to make sure we have ownership. We want to be attention to detail. We want to be very disciplined, and we take pride in what we do. Whether we're not ownership on the project, but we take pride in the equipment that we're using. Now, with all the other presentations that are going on, there's some words that have been consistent about everything that you've heard. Consistency, speed, smooth, uniformity, continuous, maintain, control, but it's all about consistency. That's what we're trying to do, no matter what it is we're looking at. So, what we're going to go over a little bit is we're going to talk about some compaction basics. What is compaction? Why are we doing it? 4 elements of compaction. We're going to talk about roller train and how they vary based on specifications and location. We're going to talk about the different roller types that we're going to utilize. Roller design specs affecting compaction, and this section is for, it doesn't matter what roller you're using, these apply. Whether it be a HOM roller, Caterpillar, Bomag, Volvo, it doesn't matter. These apply to every principle behind a roller. External factors that affect compaction that sometimes we don't have control over. And some key factors affecting rolling patterns, and the last thing we're going to talk a little bit more about is longitudinal joints. Okay, so why do we need compaction? Well, we want to build a great foundation or good support for whether we're building dams, building pads, airport runways, or roadways that we're trying to develop. Some compaction tests that we look at, some most important factors that we look at for soil and asphalt is we want a high load-bearing capacity. We want to make sure everything is stable. Good stability for that material, low water permeability. We get moisture into the base, we're going to have troubles. Extremely level. The more level we can make the bottom layers, the more level we're going to make the top layers. Makes sense, don't it? Long service life. Everybody wants to save money, so we want to have a longer service life in our equipment. High skid resistance. That ties into that extremely level. If our tires are constantly on the pavement, we got better skid resistance. If they're bouncing all around, we don't get a good ride, we don't have good skid resistance, we can have problems. So some other parameters we look at are mixed type. We have several different mixed types that are out there, not only just in Virginia, but all around the US and Canada. Everybody has different nomenclature for it. We look at different gradation curves, whether it be an SMA, open graded, fine graded mixes, and so forth. The different types of binder that we use. Regular asphalts, all the different PG grades, whether it be a modified by polymer or modified by rubberized asphalt. So depending on where we're utilizing them. We talk about some environmental conditions, about temperature, wind, overcast, and sunny. When we talk about temperature, we have to consider 3 different temperatures. The base mix, or base material, our mix, and the air temperature. 1 out of those 3 we can control. That's the mix temperature. And hopefully that stays consistent. The other 2 Mother Nature has. There are programs out there, one called PaveCool, that we can actually, and I use it on every project I go to find out, put in the wind conditions, the temperature of the base, the temperature of the mix, the type of oil, and it gives me a window of opportunity of how long I can have for my breakdown roller to compact. It's a great tool to utilize. And also course thickness. The thicker we make it, the longer the heat's going to be there. The thinner it is, like Trenton said, the faster it's going to cool down. Faster it cools down, you lose your opportunity to get that compaction. It all starts from the bottom up. We can't not get compaction on the base We have to get it from the bottom up. Bridging the material with hot mix is not going to do it, especially on the highways when the load capacities that we have today, it's not going to work. So why compaction? Well, we want to improve that material stability. We want to minimize that permanent deformation. If we undercompact things and we get wheel ruts, if it rains out, what do we got? We got hydroplaning. If it freezes, we got a skating rink. So we want to make sure we get the proper compaction. If we overcompact and we start cracking the material, when it rains, moisture gets in those cracks. You get wheels going over top of those cracks with the water. We get a hydraulic pressure. That water is either going to go further into the mix or it's going to come out. And when it comes out, it's going to take something with it. And if it's not bonded very well, normally it's going to be the material. That's the start of a pothole. That creates problems. So we want to reduce that moisture penetration by not overcompacting as well. So whose job is compaction? It's everybody's job. We need to pay attention to it. And I'm glad I'm not in Arizona to show this. So what is compaction? It's really a manipulation of material to reduce the air void content. And how we do that? Well, on the soil side, the moisture in the material is actually the lubrication to help compact everything in there. On the asphalt side, it's the asphalt. How much oil do we put in there to get better compaction? How do we measure it? On site, we're either going to use some kind of a portable device, whether it be a nuclear or a non-nuclear gauge, and it's going to tell us a certain percent of density based off of a max GMM. If we don't want to use that, typically we're going to go out and we're going to core. And the core is actually like if we were in the lab creating a puck, we can find out what the exact density or air void content is of that material at that certain point in time. And we'll set that up, basically sublots or lots or however each state does it. So what are the four elements of compaction? Well, we look at static weight, we look at impacts, we look at the dynamics, whether it be vibration or oscillation, and we look at kneading, which is more the rubber tire rollers, or we call it oscillation as well too. We can use either one. So when we look at static weight, we have the old three-wheel rollers. Can anybody tell me why we have old three-wheel rollers and we don't see as many of them today? Anybody know? The main reason why is years ago, the mixes that we had a lot of marbles in them. So they were very easy to compact. And the three-wheel rollers had a lot of PSI per drum, and it was easy to compact the mix. Nowadays, we got a lot more fractionated materials in there, and we need a little bit more than just the static weight to get the compaction process down to the air void content we're looking at. So we have rubber tire rollers. Those are great if you have imperfect surface areas. Minimizes bridging, especially if you have areas that have a lot of manhole covers, catch basins, water mains, and so on for that. If you use a steel drum, you're going to bridge over that and not get your compaction. So the rubber tire rollers help you do that. We can put it in a lot of different situations. Sometimes when you can't use vibration, we can actually use the kneading compaction of the rubber tire roller in a breakdown position if it's a thin enough lift. Because what it does is it actually massages that material from bottom up, and it brings the fines to the surface to help seal. So it works really well. But the thing with the rubber tire roller, we need to make sure we match the proper air pressure in the tires to the weight of the roller. We want to have a good contact area with that rubber tire so we get the proper kneading effect in between the tires to get the proper compaction from bottom up. If we have too much air for the weight of the roller, we're going to have a knifing effect, and we're going to move that material around an awful lot, but it's not going to get compacted. On the other end of it, if we underinflate the tires or we have too heavy of a roller for the pressure we have in the tires, it's going to have a tendency to want to cup that mix under the tire. So if you got a flat tire, it's going to actually, you'll be able to see it. It's going to make an ugly mark on the road. So key is to make sure we have all the tires, the right air pressure, and the right air pressure for the weight of the roller that we're using. And again, it compacts from the base up and in between the tires. This is an example of why we've gone to vibration. This is just an example, an extreme example, because these are round materials, but we have a weight that's off center, acts like a vibratory drum, and you can see how the material settles once it touches the glass. It has a fluff factor, and once you hit the vibration, it compacts it itself just in the vibration alone. Now we add weight to the roller, we get a better compaction effort as we go through. This one here actually shows you the difference between oscillation and vibration. Vibration, you can see it's a rotating effect of that front drum because the weight is rotating around the center axle of the front drum. The rear drum, the oscillation drum, the weights are offset on either side, and when they go around, it teeter-totters that drum forward and backwards as it rotates. With vibration, 50% of the time the drum is in the air, the other 50% it's on the ground. Creates a seismic activity, so it's very dangerous in some sensitive areas. With oscillation, with that teeter-totter effect, we have what's called a tangential compaction, forward and backwards, but 100% of the static weight is always on the mat. So now we have not only a vertical, but almost a horizontal compaction effort as well. I kind of call the oscillation a get out of jail free card. It's an awesome tool to use when you need it. This is another example of how that works. Vibration here, you have the center mass going around the axle. With oscillation, it teeter-totters that drum forward and backwards. So it's like a steel drum kneading effect. So we talk about roller trains. A lot of times we're going to have what we talked about, Trenton showed before, a breakdown, intermediate, and finish. This example shows a typical specification, say we have from 92 to 96% as our density. We want to try to achieve as much as we can with the breakdown roller, but we don't want to achieve it all. If we try to achieve it all, he'll never see the back end of that paver. So we want to get as much as we can with him, but still maintain that distance up to the back of the paver. So typically, if I can get 90 to 91% with a breakdown roller behind a paver, I'm pretty happy with that. That's why we have other rollers, because we should still have enough temperature in the mix to gain that additional compaction. Now, depending on how wide you're paving, how thick you're paving, this will vary. You might have 3 rollers, you might have 6 rollers. I've seen as many as 10 on one project behind one paver. They're flexible. We can do a lot of things, but what we want to do is we want to make sure we can achieve our compaction with the least number of passes for each one of those rollers. Now you show a certain distance for the pass count. That will vary. We don't want to have too short of a pass area because we have too many crossover areas when we start and stop. That takes a lot of time to do that. We also don't want to have them too long because now one side of the road's cooling down faster than the other. So we want to find that happy medium of what it is. So the types of rollers that we look at the static rollers. Those basically, like I said, years ago. Now they're still used for using pinching joints or finishing in the mix, or maybe doing shoulder work, so forth. We look at the rubber tire rollers, great for soil work, finds the soft spots. For asphalt, it actually brings up the fines to the surface. Combination rollers have been great for a lot of municipalities and smaller projects and things to do because you have the best of both worlds. You have a steel vibratory drum up front and you have the rubber tire kneading action of the tires in the back. Great for going up steeper elevations as well. But the most common one you're probably going to see is a dual vibratory drum roller because we can run it in vibration mode or we can run it in static mode. And usually you're going to have either front or rear controls individually, so we can set them up differently. Same thing with an oscillation roller. The only thing with an oscillation roller, when you can't vibrate, you can always oscillate because the temperature window is much bigger for oscillation and vibration, and I'll go through a little bit more of that later on. So these are some key roller design specifications that affect compaction, and these work for any roller. We're going to talk about amplitude, frequency, static weight, centrifugal force, rolling speed and frequency are tied together in something we call impact spacing. And that's very important when we talk about rollers. Drum diameter has effect on what we're looking at. Drum activation controls that individualness from front to rear, what we can do depending on the mix. Drum, water, and scrapers. Two most important things you will see and need on a roller. If you do not have a water system on a roller for asphalt, you will not be using it. I don't care how new or how old the machine is. Drum offset. A lot of manufacturers now are using hydraulic offsets. Probably the most underutilized function in a roller that gives you a lot of benefits that you can use. So when we talk about amplitude, what does that mean? Really, how big of a hammer do I have to swing? A low amplitude means we have a sliding weight away from a stationary weight. I have a smaller hammer, I can swing it a lot faster, but I don't have as big a force. I rotate it in the opposite direction, the sliding weight comes down to the solid weight. Now I have a much bigger hammer, I just can't swing it as hard. Okay, so we're going to have a more force here, but I can't swing it as fast. Here we're going to swing it fast, but I'm not going to have as much force. When we talk about frequency, all rollers are based on frequency based on a low amplitude setting. But we also have to worry about how speed affects that. So when we look at the centrifugal force of a standard roller, heavier the eccentric weight, the greater the force. The smaller the weight of the eccentric force, but the faster you do it, you get the same generated force. So we have high frequency rollers and standard frequency rollers. But when you get the high frequency the same as the standard, as far as what its max capability is, you're going to get the similar force. So if you want to calculate it, there is an actual calculation you can do, and I'm not going to walk through this, but this calculation actually works. If you don't want to use the calculation, just you look at anybody's spec sheet, we have it on there. But if you want to be smart, you can talk to someone and say, hey, I can calculate that for you. Here's an example of what we talk about impact spacing. We're going to take a roller, we're going to set it up at 3 miles per hour. We're going to set up what we call VPM, vibrations per minute, and it's going to set it up at 3,200 VPM. As I'm moving forward, I get a certain distance in between those spaces. That's called my impact spacing. Well, it's telling me approximately every space is 1 inch, and so in 1 foot, I got 12 impacts per foot. It's a key word, 12 impacts per foot. I take that same roller, I just increased the speed. I have the same VPM. My spacing now has changed from 1 inch or 12 impacts per foot to 1.3, and it's 9 impacts per foot. We start dropping below 10 impacts per foot, we're going to start feeling that in the rideability of our roadways. It's going to feel like you got a tire out of balance, is what it'll feel like. So we want to maintain a certain impact spacing. I always tell people if you maintain between 12 and 16 impacts per foot, I don't care whose roller you have, you should be able to achieve what you're looking for as far as compaction. Minimum of 12 is what I like to go with. This is another little sheet. A standard vibratory roller is a max of 3,000 VPM. If we look at this chart, we have rolling speeds up on top. We have our impact spacing down here. You can see at what point, about 2.8 miles per hour, I'm going to be around 12 impacts per foot. Now if I go to a high frequency roller, which is around 4,000 VPM, it gives me the ability to go a little bit faster, maybe 3.8, but still maintain that 12 impacts per foot. I have a few here for those that might want them. They're just little magnetic charts that slap on the roller because they're metal. And these are magnetic, so if you got an idea what your speed is and what your VPM is, you'll be able to tell what your impact spacing is going to be. So feel free to grab those if you want them. The other thing, like I talked about, maintaining that proper impact spacing is consistent speed. Most all rollers now have a set speed, so no matter how far forward you put the lever or backwards, you maintain the same speed. Now you maintain the same impact spacing forward and backwards on your pass, so you get more consistent, there's that name again, consistent impact spacing for every pass you do. You should get more consistent compaction. Older rollers, you were trying to control your speed with the levers, so you had an accordion effect of that impact spacing going down, so it would vary your compaction effort. Some things too, when you get to a certain point or a certain temperature, and it'll vary depending on the types of mix and the thickness of the mat, we start getting to the point where vibration is going to start either busting rock or creating ripples in the mat. And we're going to feel that in what we're going to do. This is an example of a project that I was down on. We had a customer saying, I got a vibration in the road and it makes a hum. Couldn't figure out what it was. And it was using oscillation. I got on a project, I see that the roller operator comes off of the shoulder they were doing at the time, and he had his vibrations on. This is a 1-foot ruler. How many impacts do you get out of there? 4. What was the number I was talking about? 12. So he'd have to do 3 passes to get what I could do in 1. But the thing is, the spacing was so far out that it was in a, I don't know if you can see that wave in the road there. It's almost like a rumble strip. They were paving this shoulder at about 75 feet a minute with only 2 rollers. The roller operator had no idea how fast he was going, what his amplitude was at, and what his frequency was at. So he had no clue. He was just trying to keep up with the paver. Mainline paving, they were paving at 125 feet a minute. We went back to the owner and said, you guys are just going way too fast. There's nothing wrong with the equipment. Because every piece of equipment, whether it's ours or anybody else's, is designed to do a certain capacity. Once you get beyond its capability, this is the kind of stuff that you're going to run into. So we got to watch our speed. High frequency rollers, we can go a little bit faster and still maintain that impact spacing and cover a little bit more area so that the paver can go a little bit faster. It also works very good when you're talking about thinner lifts because we can reduce that impact force by reducing the frequency setting. When we talk about diameter of drums, this is kind of like I would compare it to boating. With a small diameter drum, we have a much higher angle of attack. When we have a much higher angle of attack, we're going to push more material in front of that drum. And the faster we go, the more we're going to push. When we do that, the mix has to come from somewhere. Normally, we're going to steal it from behind, and we're probably going to see hairline cracks. When you come to a stop, all you do is create a bigger bump. With a bigger diameter roller, your angle of attack is a lot less. So now you got more mix going underneath the drum, better chance of getting compaction, and you're going to reduce that bump you're going to have when you come to a stop. Drum offset, like I said, one of the things that is most underutilized in a lot of things, we can pinch joints in one pass. We can minimize markings. If you have a mix that's a little tender, instead of have a dual cutting edge with both drums right one in front of the other, we can offset the drums and one's always covering up the other one. So we can reduce the marking, especially when you're looking at finishing. Moving away from curves, and I got a little video that'll show you how we can move away from curves and not tear it out. Cul-de-sacs works great for cul-de-sacs, whether you're doing interior or exterior. You don't have to worry about busting things out. And if you just need a little bit wider coverage, you can get a little bit wider coverage too. This is just an example of how that works. You're going to actually put the front drum up against the curb and the rear drum is going to be away from it. Now the only way this works though is you have to come off the curb. Don't stay on the curb, otherwise you're not going to be able to do that. But once you come off, the rear is away, it's not going to tear out that new curb that you're looking at. We look at offset with an unsupported edge. We can actually maintain our front drum 100% on the mix, and we can offset the rear drum so that it overhangs a little bit. There's several different ways we can do this. A lot of it depends on the type of mix if it'll allow us to do that. But by doing this, we can get a good consistent compaction effort and not push out the material in most cases. But sometimes the mix won't allow us to do this. So some external factors that we look at for compaction. Now everybody doesn't pave in the rain, right? That's a good thing. But sometimes we don't have control over some of the things that we're looking at. Mix design is very important. Like I said, mix temperature, consistency in the mix temperature, the mix gradation. Paver issues, we can't fix the paver issues from the roller. And what I mean is they might have the screed twisted, they might have the toe arms all wrong, there might be something wrong. Maybe the operator's not efficient enough with understanding how to set the paver up. Operator issues, bad day. Ambient temperature, again, I talk about the temperature, I talk about 3 temperatures, the base, the mix, and the air. One we can control. Base conditions, we want to make sure we have a good solid base to build on. We don't want to put it on slop because it's not going to bridge. So what is asphalt? It's basically just a combination of different sites of rock, sand, and filler with some kind of an oil. And there's a variation. We don't want to have all marbles in there because it'd be too easy to compact, and we need to have some kind of resistance for the type of equipment that we have going over our roadways. We also don't want to have 100% fractured material because now when we compact it, we have a chance to break it. If we break it, it opens up and exposes that rock to moisture. We get moisture in there, in between the rock and the oil, strips the oil off, we have a pothole. So we want to have a good combination, or the right combination, that gives us a good compaction effort. We also want to make sure our texture and our flat and elongateds are eliminated. But that's a whole other story when you come to talking about mixed designs and what we can and cannot put in it. So when we look at it, we also have to have the right gradation. We have different types of bitumen asphalt that we look at, different modifiers that we can put in it, whether it be a polymer, a rubberized asphalt, or anti-strip. Different fillers depending on what type of mix it is. If it's an SMA, we're going to have some kind of a fibers to reduce the oil drain down so that we don't have puddles out there when we're trying to compact. A lot of different things, and like Trenton said, not every mix is going to compact the same and not react the same. So years ago, with the old Marshall mix design, we had a rule of thumb. If you had a half-inch mix, you get twice as thick, we can get the compaction. But we didn't have the fractionated aggregates that we have today either. So now with the new super pave mixes that we have, that rule of thumb has changed a little bit. So now that half-inch rock, which is our maximum size rock in that mix, we want to lay at least 1.5 to 2 inch mat so that we got something to compact to and we're not breaking what's in there. Because if we don't, we're going to have what they call white topping or crushing of the gravel surface. We start doing that, I can always tell when I go down a road which side of the mat was laid last by which side of the joint has failed first. When we look at mixes, anytime you can maintain temperature in the mixes, you have an easier chance of getting compaction, easier chance of moving it around, easier chance of doing a lot of handwork. As soon as things start stiffening up, we have a chance of not getting compaction, segregation, and it looks really bad, and you could possibly have raveling down the road. One of the other things we look at when we look at different projects is we want to make sure we have the right size roller for the project. If I'm doing a small cul-de-sac area or city street, I want to have something that has maneuverability, but still has the compaction force of getting the compaction I need with the material I'm doing. I don't want to have a big 84 wide inch roller, 14 ton, trying to get around here. I'm just going to tear that mix up and it's going to look terrible. So understanding where you're going and what you need to do, have the proper roller for what you do. Sometimes you don't have control over that. I know contractors, they just ship stuff out. This is what you're dealing with. But they know they're not going to put in a big roller in a small project like this. So when we look at different temperatures, and these will vary depending on the type of mixes, again, we want to get the most initial compaction we can with that breakdown roller in as minimal time as possible and still maintain the temperature in that mix. Because now if we don't get everything we need up here, we get a better opportunity with whatever's behind there, whether it be a steel drum, rubber tire, or whatever it is. So things that affect that cool down, our mat thickness, our temperature again of base and outside, the mix laydown, is it windy out, is it sunny out, is it overcast, is it misty? Those things all have an effect on it. So when we look at grading our material, we don't want to have this to pave over top of. This we can mill and fill. This we're going to have to do something other than mill and fill. If we just mill and fill this, we're just putting a Band-Aid on a problem, and it'll come back. So when you look at preparing your roller, you want to make sure we do a walk around, looking for anything out of ordinary. Check the water system. Like I said, the water system and the scrapers are the two most important things on a roller. If they don't work and the scrapers are wore out, we're going to use a lot more water. You use a lot more water, you're going to spend more time behind the water truck than you are behind the paver. And the paver's not going to wait for you, trust me. Check the lights. More and more people are doing night work, so we're going to have to check the lights. Fluid levels, make sure those are all where they need to be. Again, check the scrapers and make sure they're in the right position. If you're traveling down the road with it for a long distance and you have the scrapers on the drum, that's what wears them out real fast. You want to take them off the drum while you're traveling down. Once you get there, put them on, make sure the water's on, and start from there. You'll have a lot longer life out of those scrapers. Allow for the equipment to warm up, but just like anything else, get to know the equipment. When we're using a vibratory roller, we always want to make sure we stop vibration before we go into reverse. I actually ran across a guy up in Canada that kept the vibes on when he went forward and backwards, never shut them off. And he couldn't understand why we had so many bumps in the road. Choose the amplitude and frequency to match the job and the mix that we're trying to do. I always try to start out on low amplitude with a higher frequency. Less force, less damage to the material. If I can achieve what I'm looking for with that, I have a better opportunity to make a smoother mat all the way across. If I have a thicker mat, sometimes I'll start out in low amplitude depending on the mix. I might be able to achieve it. But normally you can go to a higher amplitude, because if I start out on high amplitude, I have no other place to go higher than that. So I always start out on low, and if I need to make some changes, I can go up from there. On hills, we want to vibrate uphill, but we want a static downhill. If we vibrate downhill, you'll have more mix at the bottom of the hill than you will at the top. And you'll have a lot of hairline cracks in the mix because it's dragging. Typically, for most mixes years ago, 175 degrees is about the max you want to use any kind of vibration on. That will vary depending on if you've got a polymer modified material, how thick it is, and so on. So 10 commandments we look at. It's to roll as closely as possible behind the paver, but do not hit the paver. There's a lot of guys that break down rollers, they try to come up as close as possible to the paver and just touch it and then go back. Number one, it's a waste of time. And number two, it's a safety issue. A huge safety issue, because a lot of times the guys on the street aren't paying a lot of attention. And if they walk off, that roller's not moving. It wastes time because now you're wasting time trying to get as close as possible. If you're at least a length of the roller away from the back of the paver, that's as close as you need to be. You don't need to be any closer than that. Absolutely. There's a lot of things that could happen. Again, when we compact, I always like to compact from the bottom side up. Most all roads have some kind of a slope to them. And we have troubles with joints. So if you start at the joint and go out, you're pulling all the mix away from that joint. By doing that, you just have opened up the chance to have a bad joint. You start at the bottom and move your way to it, so you move all the mix towards the joint. You have a better chance of making a tighter joint. Compact the seam first if you're next to a hot mat, or if you're paving an echelon. Otherwise, I always like to leave that, because if you're starting on the bottom side, you're letting that mix warm up that cold joint. When you let it warm up, whether you have it tacked or anything else, it has a better chance when you compact it to bond with that joint versus trying to compact it before it has a chance to warm it up. Again, deactivate that vibration before reversing. We always want to change our roller speed gently when we're starting and stopping. We want to reduce that tearing of the mat or building of a bump. Want to move forward and backwards in the same track. I had a guy up in Canada, again, Canada, was doing an S-curve. And I said, what are you doing? He says, I'm covering more area. I'm like, no. We want to go back and forth in the same path. We want to change the track on the cold side so that we can reduce our marking, reduce our bumps that we're going to have, and tearing of the mat. Roll in parallel tracks next to each other. Water the drums sufficiently. I tell everybody we don't need to have Niagara Falls coming off that drum scraper. You only need enough moisture on the drum from keeping to pick anything up. You want to spend more time behind the paver and less time at the water truck. Never leave the roller on the hot mat, but 99% of the time, every time I go on a project, when the paver stops, where's the breakdown roller? Right behind the paver. If you're going to stop behind the paver, hopefully you can get off and get onto a cold mat or a shoulder somewhere. But don't sit on the hot mat. Your eyes should always be on the drums to make sure you're not picking something up, but they also need to be in front and back of the roller so you're not running anybody over. You want to be conscious of that. Again, there's that word, be consistent. That's what we're looking for. So after finishing, we want to make sure our equipment's parked out of the way. We don't want to have it close enough to where someone's going to run into it. That could be a problem. Inspect the drum and scrapers. If you're going to be traveling, make sure you have them in the up position so they're not wearing out. Inspect the water system, clean the filters if you have a chance, because I've seen some of the water everybody uses. Some of it's not the cleanest stuff. If it's got a risk of freezing, we can either drain the water tanks or we can put in antifreeze in through the system. Pick up and move your trash off belongings. We had one guy one time said the seat locked up on his roller. We couldn't figure it out. We brought it into the shop, but we noticed there's a bunch of chicken bones on the dash. We opened up the rails, and there were so many chicken bones jammed in the rail, we couldn't move the seat back and forth. So just some little things like that. Some equipment has battery switches that you can disconnect the battery. The new Tier 4s, not going to be so much with the battery switch. Some key things affecting rolling pattern. We're talking about basic rolling techniques. Our paving speed, number of passes is different than the number of coverages. And then we're talking about joints and edges. So again, never stop a heavy roller on a hot mat because you're going to create dimples. And you're going to have a hard time getting those out. We always want to overlap at least 6 inches because even that bow wave I talked about in the front, you have a bow wave to the side of the rollers too, so you want to make sure you cover that over. You're not creating more of a bow wave on the side. Again, smooth start and stops. Most all newer rollers have built in to where if you're moving forward and you slap it in reverse, it has a coast factor. And it'll slow down on its own, and it'll go back on its own. Paver speed, this is actually a little worksheet that actually you can utilize, and if you change the things that are in gray, it'll tell you if the right rollers are set up for the paving speed that you have, how wide you're paving, how fast you're paving, speed of the plant, number of trucks. You can go in and try that. So if you change the numbers in here, because of time, I'm not going to do that. But it's a great little thing to help balance things out to make sure you got the right rollers for the project you're trying to do. All right, some basic roller techniques. Always stop on an angle, whether you're at the paver or the back. The best is if you can come off the mat at any point in time, you don't have to even stop. That's even better yet. But the reason we stop on an angle is when we come back in this direction, we can come and we have a better chance of rolling that bump out versus straight on. This is an example of why we do that. It shows it with just a ball of clay. And we're going to put a stop mark in it perpendicular. Now we're going to act like we're going to try to roll that bump out. Well, guess what? There's not a chance we're going to get that bump out, and we're going to create a bump. Now, if we stop on that angle like we talk about, even if we hit that angle straight on, we have a much better chance of rolling out that bump and reducing that bump at our stop position. So that's why we always stop on an angle, whether it be right behind the paver or at the end, or at the beginning. Number of passes. Now this is one where I go around and travel. I always ask everybody's definition of what a pass is because no one's the same. My definition of a pass is if I am going in one direction, that is a pass. If I come back in the same plane, that is a second pass. There's a lot of places I go to that up and back is one pass. So you have to understand that, especially if you're talking to someone that's running densities and we're setting up a roller pattern. We want to make sure that we're there for the right ones. Pass count's always going to be an odd number. If you count them the way I do, it's going to either be 3, 5, 7, 9. It's an odd number because the odd number is catching you back up to the paver. If you say up and back is 1 pass, it's going to be 2.5 passes, 3.5 passes, 4.5. Your half pass is catching you back up to the paver. Now, number of coverages is different. Number of coverages is basically saying, how many times do I have to cover this mat with my roller? So you want to make sure you're doing the minimum number of coverage passes so that we can maintain up. If I had a roller that had 3 coverage passes, I'm doing more work behind that roller or paver, and I'm not going to see the back of the paver. So having the right width roller for what you're trying to cover and reduce the amount of coverage passes, I can have a better chance of staying up to my paver. Again, we want to change our rolling passes at the cold side. If we have a crown in the middle, again, go from the bottom to the center, the bottom to the center. Bring all that material up to the joint. This one here, paving an echelon, this third pass is going to alternate between each roller when they're done with their pass, so that the third pass is always being altered by each roller. If this roller is doing all 3 passes, this guy's going to be doing a lot of sitting. This guy's going to do a lot more working, so we always alternate the passes. Typically, a 5-pass pattern, up and back. We don't want to go up and back in the exact same plane. We want to offset them just a little bit. We're going to come to the next side of the pavement, do it again. If we don't achieve our density, we're going to go back and start over again. We're going to come back and do our 5th pass here, and so forth. Now, if we only have a 5-pass pattern, or we're going to catch our last pass to catch up to the paver, where does everybody go? Right up the middle? Why? If we're starting our compaction on the outside edge, why would you not want to drop this down to the outside edge? Now you're going straight into your next set of passes. Here, you're going down the middle. Your wheel paths are actually on the other side of what you're trying to do. Now you have to turn into your pass. Every time you make a turn, you have a chance to create a bump. I want to reduce the number of bumps that I'm doing. So I'm going to have my back. I either tell them go on the low side or whichever side you're having struggle with compaction. Most of the time it's the outside. So I'm going to have him go that 5th pass here and start up his next set of passes without turning. Now this one here is one I don't agree with. Can anybody tell me why? What was that? Well, if you think about this and you think about temperature, okay, I'm actually going 1, 2, 3, and 4. I'm catching that outside edge. And now I waited all that time and I'm going to catch that 5th one coming back up here. But we have a temperature difference of what I originally compacted to what is uncompacted. And what happens is this line right here becomes a slip plane. And you're going to see that mix do this on you. Even though it's all homogeneous, you're going to see it split. You're going to have hairline crack all the way down there. Pass 5 to me would be pass 2. I'd come up and go back the same way. Now the temperature is not different enough to where I'm not going to get that slip plane. As soon as you get that big enough difference, because you're not going to be able to get this compacted down to that level because of the temperature difference. 2 confined edges, I'll just find the low side and go to the high side. Best way to roll the joint, don't drop it. Hey, you're still awake, I'm impressed. First pass, we talked about it before, stay 4 to 6 inches off that joint. And again, this is a way I've seen it work the best to get that joint compaction, because a lot of states now are going to a joint density specification. This is one way you're gonna achieve it. When you come back in the second pass, you're gonna do that static. We don't want to do it vibratory because all we're gonna do is bust up that cold side. That's the side of the joint that'll fail first if we start vibrating on it. But there's a lot of people that want to do that. What we can do with oscillation and an offset, we can do it all in one pass. Front drum here, rear drum's offset, rear drum's running oscillation, front drum's in vibration. We get full compaction effort across that drum. If we don't, like you talked about before, bridging. We're going to bridge here. This mix from here to here is not going to get compacted consistently. What's going to happen is you're going to have a pinch point right at the edge, and you're going to have a white streak going down the road, and you'll wonder why. So using oscillation will not damage that cold joint. And this just shows you exactly what oscillation does on that cold joint. It'll compact it down to the cold side. It'll massage that hot mix into the joint, but it's not going to destroy the cold joint because it's just scooting across the surface. It's not vibrating, damaging, and breaking that rock. Showed this picture before, very similar. We always want to overlap about 6 inches on a hot mat. We don't want to go any further than that. We definitely don't want to go over half because what's going to happen, just like pinching a joint, all that roller is going to do is sink down into that cold side or the hot side, and you're going to create a bump when you come off. And we don't want to do that. Again, there's a lot of different ways we can roll unsupported edges, same with joints. We just want to make sure if the mix is capable of allowing us to do that. Hang over that 4 to 6 inches, depending on the type of joint we're trying to make as well too. Make sure that if the mix holds up, best way is to offset your drums. Do it all in one pass. That way you don't have that temperature difference and you don't have to worry about it. We do not want to go 6 inches off and then come back right on the joint. We don't want to do that because now all we're going to do is we're going to probably create, especially if the mix isn't at the right level, we're just going to create a worse joint than what we had before. The lute man. Best thing the lute man can do is throw away the lute. If we're going to do anything to that joint, we want to bump it. We don't want to cast it over because as soon as you cast it over, you open up that joint again. We want to make sure that material stays in that joint. Again, casting it over there, it can also show that it's going to be segregated. You might have a false impression that this is segregated mix when it's really just the overcast of the lute. Here again, on the hot side, we're going to bridge here, but we're going to pinch point that drum there. Now you got all this material in here that's not going to get compacted. Not to the level we want to. Same thing, we can even do that push out on the joint, so we have to be careful. Every mix is a little bit different in how it's going to react. The crown of the road, do not run on the center of the crown of the road and teeter-totter your drum on either side. That is not what you want to do. That's going to create 2 cracks, usually run here and one here on either side of that joint. Now you got 3 cracks. You don't want to do that. Keep your augers full. Have extensions out here so that we can contain the mix a little bit easier. That screed's not working so hard, especially when we got more mix on the side. I don't care if it's a centerline joint or shoulder joint, don't cast it over top of the center. Don't want to do that. It doesn't look pretty. If anything, we can also use a rubber tire roller in a joint. There's some places that do use them, some places that don't. Here, another good chance to get a nice tight joint. There's some other things we can do. Infrared heaters on joints, a little expensive, they work. Joint adhesive, very time and labor consumption. Echelon paving is probably the best to reduce any kind of a joint or create the best joint. That way you got hot on hot, you're going to get a good joint. You probably won't even be able to tell where it is. Mill and fill the lane. We can cut back the joint itself if we need to. Overband 4 inches with PG binder. Again, that's an expensive way of doing things. We also, after we're done compacting and paving, we can go over and seal the top. But that's just a cosmetic fix. What we want is a nice solid joint that's not opening up for years and years. And that's what I got.